All right, next up we have synthetic routes. So as mentioned before, what if you're given the name of a substance that you were asked to produce, and your job is to figure out what you would need to make that substance? So basically what we do is work backwards. We can use this schematic to help us, though this will not be provided to you on the test. You need to know all the different reactions we've talked about and how they are all related to each other. I'm actually going to start on this slide here, though it's not 100% accurate with the current syllabus. This kind of just is a more simplified form, and then we'll get to the more complex one next. There's also a diagram similar to this on page 512 in your textbook. And so we can start wherever you want. We can start with an alkane. And so you need to know how to convert an alkane into a halogenoalkane. This is accurate in that you do need the mechanism for this reaction. So what kind of reaction, what type of reaction, what class of reaction occurs here where you take an alkane and you turn it into a halogenoalkane? Go ahead and label that on your notes. That, of course, would be the only reaction type that we learned involving alkanes or free radical substitution. So that would get you the halogenoalkane. Let's continue going down. So how about taking that halogenoalkane that is produced and turning that into an alcohol? Once again, a mechanism for this reaction is required. And so go ahead and pause and think about that type of reaction. So conversion of a halogenoalkane to an alcohol involves a substitution reaction, this time nucleophilic substitution. So depending if that halogenoalkane is primary or tertiary, we have either SN1 or SN2 mechanism. Continuing down, how about converting an alcohol to a ketone? Go ahead and pause and think about that. Right, of course, this involves the oxidation of a secondary alcohol. Oxidation of secondary alcohol will lead to the formation of a ketone, so we can use potassium dichromate and make that conversion possible. And again, be thinking about how to go backwards as well, like working your way backwards. So what if you were given a ketone? Say, all right, you want to make this particular ketone. What are the starting materials needed for that? And we need to work our way backwards. Well, the ketone can be used, a ketone can be produced by the oxidation of an alcohol. We can get that alcohol from a substitution reaction involving a halogenoalkane, and we can get that halogenoalkane produced via free radical substitution reaction involving a halogen and an alkane. Next, let's go here to alkenes. And so you need to know how to go from an alkene to a dihalogenolalkane. And let's just go ahead and add that. Say mechanism is required for this. So what kind of reaction is it where you take an alkene and you turn that into a dihalogenolalkane? Go ahead and pause and think about that. That is, of course, an addition reaction. Addition of a halogen will give you the disubstituted halogenoalkane. How about alkene to just halogenoalkane? Again, a mechanism is required for that reaction. Pause and think about that. So this, again, is an addition reaction. This time hydrogen halide and an alkene will combine to make a mono, if you will, halogenoalkane. How about alkene to alkane? Again, a mechanism is required for this. Pause and think about that. Here we're talking about addition reaction once again, hydrogenation reaction, not hydration, hydrogenation, adding hydrogen. Make sure you know the catalyst and temperature that this reaction occurs at. Mechanism once again is required. How about alkene to alcohol? I don't know if I made you do the mechanism for this one, so maybe not. So we'll put a question mark here for now. I can confirm that. So how do you convert an alkene to an alcohol? Pause, think about that. So hopefully you're seeing a trend here. We have addition reactions. So addition of water this time to an alkene will result in the formation of an alcohol. And lastly, alkene forming a polyalkene. What kind of reaction is this? This is an addition reaction. This is an addition polymer. So ethene and ethene can combine to produce polyethene or polythene, sometimes it's called. And so that's our addition polymer that is produced. How about up here, dihalogenolcane to trihalogenoalkane or tetrahalogenolcane? This again can occur via free radical substitution, where you first end up with the monohalogenoalkane, which can then be converted to dihalogenolcane. So I kind of skipped this part. So free radical substitution to get here. Further substitution will get you the trihalogenoalkane or the tetrahalogenolcane. All right, what's left? Let's go here. Back to alcohol to aldehyde. How do you turn an alcohol into an aldehyde? Of course, this would be a primary alcohol. So this is going this way would be secondary alcohol. This would be primary alcohol. So primary alcohol to aldehyde, this is oxidation using potassium dichromate. The alcohol to aldehyde, this can be accomplished using distillation. If you heat the alcohol in the presence of an oxidizing agent under reflux, so maybe we should add that. So this is distillation. You can further oxidize the aldehyde to carboxylic acid, again using potassium dichromate and heating under reflux. This graphic is a little bit different. I have a couple additional things on here. So same as before, except this time we have, how about we go from a ketone to an alcohol? So opposite from what we just saw. To go from alcohol to ketone involves oxidation. So the opposite of that involves reduction. So of course, we're talking about formation of a secondary alcohol here if we reduce a ketone. Likewise, on the other side, how do we go from aldehyde to alcohol? That involves reduction of a aldehyde to form a primary alcohol. Again, we can go back and forth here between aldehyde and carboxylic acid. Aldehyde to carboxylic acid, of course, oxidation. Carboxylic acid to aldehyde would be reduction. Same thing here. Typically, we don't go directly from alcohol to carboxylic acid. So we're going to go alcohol to aldehyde and then aldehyde to carboxylic acid or vice versa. Something that was not on the previous one is here, formation of an ester. This involves reaction between an alcohol and a carboxylic acid. So this is a condensation reaction or esterification reaction. And then across the bottom, benzene to nitrobenzene. All right, across the bottom from benzene to nitrobenzene, this is an electrophilic substitution reaction, nitration of benzene. And then from nitrobenzene to aniline or aminobenzene or phenylamine, whatever you want to call it, either one of those is fine. That involves the reduction of nitrobenzene. Again, make sure you know the reaction condition, any reagents needed for that reaction to occur. So I have mentioned several times that even though it seems pretty extensive what we're doing here, we're barely just scratching the surface. And so I just wanted to point out a different diagram, a little bit more complex than what we need to know. So this is, again, not complete. This is not an exhaustive list of all the different reactions involving organic compounds, but this is quite a bit more than what we're doing with this class. So use this for future reference. If you need some help converting from one substance to another, not sure what kind of reaction or what the reagents are that are needed for that reaction, you can refer here. All right, that concludes our lesson and our unit on organic chemistry. Thanks for watching.